Welcome to Startup TV Boston. My name is Michael McCarthy, and I'd like to welcome my guest, Eli Dagger. Welcome,
Hi.
Eli.
Thank you for having me.
Startup TV Boston highlights significant and special startup projects that are in the Boston area that I feel should be brought to the attention of the community. And I'm a teaching assistant at Harvard University in the Entrepreneurship and Innovation class, and Eli was one of my students last year. And Eli, this is actually your second time on the show, and now you have another startup. So you're starting to become a serial entrepreneur.
Yeah, I enjoyed it so much the first time. I had to do it again.
So tell me about your second startup. What's it called? What's it about?
Well, this one is a hardware startup, and it's called Evercharge. We're pretty much trying to solve the problem that people are having with their phone battery life, and we want to provide them a charger that lasts for extremely long time without having to constantly charge it.
And how does it work?
I guess you'll find out in the presentation.
Part of the presentation?
Yeah.
So tell me, how did the idea come to you initially?
Well, the roots of this idea go back all the way to 2010 when we lost power at our home during a winter storm. And at the time, I was not happy with the solutions with the power generator and all that kind of stuff. So I started looking into other ways to generate electricity. But after doing some research, I decided to shelve it, and I didn't think it was feasible for something so big. But after a couple of years, I was traveling overseas, and I had a really long flight, and I was not impressed with my phone battery. Mm-hmm. So I started sketching up the process on the paper on the plane. I had a long time to think about it. I designed the whole thing from ground up. Well, obviously, that's the initial design, so it changed a lot since then. But that's how it all started when I was traveling, and I kept on running out of phone battery.
So it's basically a charger?
It's basically a charger, yes, but that you don't constantly need to charge like the ones that we have in the market right now, which basically are just an external battery that you have to charge, and it will hold enough charge from anywhere from 1 to 5, 6 times. This one, the charger should last you anywhere from 3 to 5 years without having to recharge it again. That's
Wow.
what we're hoping for. That's what we're going for, and that's where we need the help from the VC to bring that to market.
So you might be Elon Musk's best friend soon.
I love this guy.
Are you listening, Elon? Could we take a look at your presentation?
Sure, let's get started.
Okay, so why don't we pull it up, and let's begin. Let's hear about Evercharge.
All right, so Evercharge, basically we want to provide you with unlimited renewable energy in your pocket. A little background about it. So currently there is high demand for mobile chargers due to the increasing usage of power-hungry devices. Think about smartphones, drones, IoTs, tablets. Now smartphones are the most common product that we use today. Most of them don't last 10 hours on a single charge in heavy usage, which is very inconvenient for all of us. Now there are a lot of solutions in the market. None of them really solve this problem. You got the external batteries. They are very common. Their price range from $5 to $200. They can charge your devices anywhere from 1 to 7 times, but you typically need to charge them before every usage. You got the solar. These are more expensive and bulkier. You need sunlight to charge your devices, which is not always available, such as indoor, when you're on an airplane, in cloudy weather, at night, so it doesn't really work. You got the hand crank. These are very common. They're very cheap. They're very slow in charging, and you need to use hand crank motion to charge your device. Imagine sitting next to somebody on an airplane, and they're cranking up their charger. So you also got the motion ones. This one is Ampy. It costs anywhere from $100 to $150. It uses body motion to charging your devices, and also a little bulkier. And the last one we found was the boiling water one. This is definitely not very convenient. It's fairly large, and it's a fire hazard. You cannot use it indoor. and it's very slow to charge your devices. Now, the problem with all these with all these solutions is that they all depend on energy sources that are not readily available. Now, example, think about on a plane. Let's say you run out of a battery of charge from your external battery. It's really hard to recharge it, or your solar charger. You cannot really use it. You're not going to be running around the plane to charge using your motion one. And of course, the other two, you're not going to be using them on an airplane. And also, most of these are not very portable, and they're not easy to fit in your pocket or jacket or purse. Now, our solution is basically a self-sustainable generator and charger that doesn't need to be constantly charged. It generates electricity that is self-sufficient to keep itself running while it charges other devices with no need of an external power source or supply. Think about oil, solar, wind, or just AC/DC. It also generates unlimited renewable electricity using its own electromagnetism. And it is much safer than the lithium-ion batteries that can overheat and catch fire. Think about what was happening with Samsung lately. Now, our team is very qualified to run this venture. Myself, Eli Dagger, I'm the founder and CEO. I have a bachelor in computer and electrical engineering. I have a master's in management and over 10 years of experience. Greg, my partner, he's a CTO. He's got a BS in electrical engineering, MS in management, and he's got a 5 years experience in PCB design and layouts. And we got other members who will be joining us as soon as we move forward with this project. And they're all excited to jump on board, such as Chan. He's got over 12 years of experience. Rob, 4 years of experience with an MBA, and Nan, 14 years of experience. Bill, he's got 4 years of experience. He worked on several government projects, from nuclear to submarines to planes. So we got a very talented team. In simple terms, we are combining wind power and electromagnetism to create a self-sustainable system. Think about it this way. Instead of using wind power to spin the blades, we are using an electromagnetic field generated inside the wires, which are coming out of the alternator. So we came up with a very innovative way to start up the system and manage the initial charge to recharge the system as it's charging other devices, so it lasts a very long time. Again, this is a very complex system, but this is the simplified version of explaining it. But we're not gonna go in much more details over here because we are not gonna share the intellectual property today. Basically, our technology is nothing new, but our process is. Our patent-pending process defines the way our system starts up and magnetizes itself, and then how it charges itself and other devices in a self-sustainable feedback system. Our current prototype is basically a proof of concept. We currently have a working prototype. Our best results so far were 54 times gain of the initial input. Think about this time. So you get an initial charge that's lasting you 54 times. A lot of improvements need to be done to get a fully working prototype, including designing the components. They have to be custom built. Right now we're using components that are off the shelf, and they don't actually follow our patent process. And this is where our unique way of approaching this project is advantageous. Is basically we are designing everything from the ground up, and we currently don't have that. Now, again, due to the public nature of this show, we cannot provide further details or videos, but we will happily provide more info to any VC that contacts us. The product line, basically we will have one basic model. It will have one input control. It's just a start button and a USB output type. It will be rated 1.5 amps. And the dimensions would be anywhere around 8 centimeter to 2 centimeter. To put that in perspective, this is the size of a typical iPhone 6 or 6S, and that's how big this charger will be. And then we will have a Pro model. It will be, this one is definitely an option. It will have a start button and a voltage control. The voltage you will be able to control the output voltage from 5 volts all the way to 12 volts. and it will have a price range around $150, while the basic model will be around $100. Now, the estimated cost to build this device so far, it looks like it's going to be around $10 to $15. So we will have high profit margins on these devices. And optional, we will have a smartphone app that displays useful info and turn on the charger automatically when the battery is low. Think about when we're charging the devices wirelessly, and it will be seamless for the user. We have a good future growth plan. We will be adding more power for faster charging, 2.1 amps and 3.0 amps, which is the latest fast charging. And we will support wireless charging in the future, maybe through partnership. We will license our technology so we can create a built-in chargers. And think about a drone. Most drones right now only last about 20 minutes up in the air. We want to create built-in chargers so they can last for hours, days, maybe weeks, without having to rely on solar or any kind of external power. We can scale up and scale down our technology to support other customer needs. Think about laptops, again, drones, cars, and we will support IoTs by creating partnership or API integration standards. And also we want to expand into new areas where power support is needed but difficult to reach. Think about like third world countries, light fixtures, cameras, remote cameras. Our market size, we can target different markets in this area. We will initially target smartphone users. This market is about 1.46 billion units in 2016 and is expected to grow all the way to 1.8 billion units in 2018 before it starts getting saturated. And we also, after that, we want to support IoTs, drones, action cameras. Cisco estimates that currently, IoTs are about 25 billion units in 2015, but it will be about 50 billion units in 2020. Global market for smartphone battery packs is expected to grow to around $11 billion by 2020. Imagine if we can capture 10% of that market by then, that's about $1 billion of revenue. Another way to look at it, if we capture 0.5% of smartphone users, that's about 7.5 million units. If we multiply that by $100, the basic model price, that's about $750 million revenue. Finally, why do we think this is a good investment? It's a diverse consumer base. Again, the market is really big, and with our future growth plan, we will be tapping new areas. And it's a minimal innovation so far. External chargers are using the same old technologies. Think about lithium ions, which has been around for like 30, 40 years, wind, solar, but in different looks and sizes. We are offering a new way and process to generate sustainable electricity that can be scaled up or down. Disconnected brands and consumers. If you ask smartphone users to name one or few external battery makers, there's a high likelihood that they cannot name a brand, even if they own the battery pack. There are a few brands out there, but there's no dominant player. And finally, confused and frustrated consumers. There are many options on the market with no clear distinctions. Most consumers don't know the difference in many products and why some cost more than others. This is leading to confusion and frustration. We are offering a unique product with very distinctive technology, feature, size, efficiency, and marketing. Basically, our model is not just a charger, it's a generator. It's the last charger anybody will ever need. The technology can be scaled up and down to work on other product categories and even built into them. Thank you, and I guess we'll be moving to the next segment of the show.
Eli, thank you. That's an amazing idea.
Thank you, sir.
Well, if you had this in the Harvard class last year, you would have gotten A++. This is pretty big stuff.
Well, I was working on this idea back last year when I was in the class, but during that time we were still going through the patent process, and we didn't get the patent pending status till after the class in the summer.
So tell me, how did you come up with the idea?
Basically, the idea is, again, it started because I was frustrated with what's out there. I do not like the solutions right now. I don't think it's a very good idea to just keep on charging your device and other products like external batteries. I keep on forgetting charging on my phone as it is. I don't want to have to worry about charging something else, so I wanted something to be totally independent of any external sources.
So it's actually not a battery charger, like you said, it's a generator.
It's actually a generator.
It's a standalone power plant.
Exactly, that's the whole point.
Now, does this particular technology exist somewhere else in a different format?
It does. In some ways, it does. See, as we explained in the presentation, this is not a new technology. Basically, we're combining two already existing technologies, but in a more efficient way. We're basically creating a smarter way to manipulate and manage that initial charge. This still needs a battery at the beginning, a smaller battery. But then we're taking that charge and extending it extremely long time by using a unique way to manage it. It's a more smart system than what has already existed. So basically, one of the reasons why it took us so long to get this far is because we didn't believe in ourselves at the beginning. When we first came up with the idea, I started researching it. And then I kept on seeing a lot of people trying this for years, for decades. People have been trying to come up with something similar to that. Mm-hmm. But their biggest mistakes were that first, they were trying to create energy, and they called it free energy devices.
Yes.
So there is no such thing as free energy device. You cannot create energy. And they're trying to target something much larger, and also they didn't know how to start it up. So our unique approach is how to start up the system, which has never been done before. We're combining electricity, mechanical, physics in one startup system. And we're using smart controllers to manage that electricity. And also, don't forget, we're designing all the components from ground up. So basically, right now, the problem with our current prototype is that we're using off-the-shelf components. But in order to achieve better results, we need to design everything from the start.
So once it starts, does it shut off, or does it?
Oh yeah, you can shut off.
You can shut it off.
But it's recharging that battery that you use at the beginning to charge it up. So basically, it charges up the battery while charging other devices, and while keep itself running. But then once the battery is charged, it shuts off the charging to that battery. Mm-hmm. And but it keeps itself running while it's charging other devices.
Does it get hot?
No, we will be adding sensors and safety components, I guess, to just fail-safe kind of components, measures.
So why do you think you're going to succeed when others have not doing something similar?
Well, again, it's basically because they were approaching it in the wrong way, and they were trying to come up with something much larger. They wanted to run refrigerators, homes, using that, and again, they couldn't figure out how to start it up, and they tried to create energy instead of managing the existing energy. And they didn't try to design the other components. They just tried to use what's already exists.
I see. And are there any barriers to entry for you to come into the market to actually make this?
Well, the biggest challenge for us right now is coming up with a prototype. Right now, we have just a proof of concept. Mm-hmm. We don't have the resources or capabilities to come up with the actual product. And that's where we need the help. Right now, what we are actually asking for is mostly money or help to bring this product, to create a product that we can start marketing.
So if all the resources of the world were available to you, mm-hmm. what do you need to make a prototype?
We need a skill set and of course, like the resources, like such as printers, like 3D printers, or some kind of help in designing these components. That we don't want to reinvent the wheel, but we want to redesign them in a way that works for us. So basically, we need the help in creating these components that's been around for a while, but we just need to find the right expertise for that. We are learning it on our own as well. We got the books. We've been learning it for 4 years. And as you see, my team is extremely talented, and they all have good backgrounds, but we just need that additional help to build the product.
So you need 3D printers to build the components.
Yes.
And then you need a team of engineers to actually design the specific parts.
Yes. We actually have the team of engineers. We really need the place.
The place.
And the resources to help us build them.
What about money? Do you need some money?
I mean, definitely money would be great, because then we can hire external companies to help us. We definitely prefer to do everything in-house, but if money is available, that'd be the best way to spend it wisely. Is to hire external companies to help us, like specialty companies.
So how much do you think you would need to get a prototype?
At first, we don't need more than 10,000 maybe to get a working prototype, maybe 10
That's
to
pretty easy to do.
20,000. But of course, in order for us to quit our jobs and concentrate on this and hire the right skill sets, we probably will need a lot more than that.
I mean, that's cheap enough for a Kickstarter or credit line on the credit cards.
Yeah.
You could bootstrap this.
We could, and we actually did. I already spent about $10,000 out of my own money on patent and buying components and testing it out. And that's not including the hundreds of hours that we've already spent collectively between me and my other founder, the CTO, on this. So we spent a lot of hours on this, and about $10,000 already out of our own money.
Have you spoken to any tech venture capitalists or angel investors in the area?
I contacted one, and that would have been perfect for this. Bolt, here in Boston. I contacted them. They didn't even look at it. They didn't even bother to look at it, because they already mentioned on their website they are not interested in chargers. And we contacted them. They just, as soon as we mentioned that there's some form of a charger in there, they just, we're not interested in that. They didn't even open up our document, because we use DocSend, so we know if somebody opened up a document. They didn't even open it. They didn't even look at it. But that would have been perfect. And we contacted a Harvard Innovation Lab as well. The problem is that I'm not a full-time student over here, so they cannot help me.
Lucky for you, I actually have a meeting with Harvard Innovation Lab after this show, so
That would be great. That would be great. Yeah.
I'll talk to them, because I think this is probably where you would belong.
Yes.
And what about I mean, this really isn't a venture capital idea right now. For $10,000, you're really looking for an angel investor. That's
Yes.
a smaller amount of money.
But again, really, what we really need is really the help to build something. So the money alone is not going to help us. It's really, we need like a venture similar to Bolt, where they help startups build the product, create prototypes. They actually they have like a multi-million-dollar lab that helps you create products, and that's what we really need.
So where do you think your large growth potential would be? Let's say that you got the smartphone market. What I didn't realize a few weeks ago when I bought a large charger, it only does phones. There are no external chargers for laptops.
No, there are not.
Could you do you really don't have a charger, you have a generator. It's
Exactly.
actually its own product class.
Exactly, yes.
So now that you have your own product class, and it's a generator, could you make a generator large enough to power a laptop computer?
That's the plan. That's the plan. We are targeting at first the typical USB chargers, like stuff that needs 5 volts, which is mostly like smartphones and smartwatches and all these devices, because they are the biggest market right now. And of course, it's much easier to create something smaller at first. But as we perfect the technology, we can scale it up. And again, as we said, we can scale it down as well for something that needs less or maybe smaller, that we can fit it in certain devices. But the plan is to scale it up. Of course, we don't want to go all the way up to 120 volts because I don't think we're interested right now in going that far. I don't think it's feasible with these technologies, but it could be. But right now we're concentrating on the smaller item things. But think about the future. We could pretty much, if we are successful at creating something much larger, we could end up, hooking it up into your Tesla, for example, where basically you don't have to stop all the time to charge it up. It could provide some electricity to your car to keep going for a longer time.
It would be almost a perpetual motion machine.
It would be almost like that, but we're not sure if that's feasible. But again, at first we want to concentrate on the smaller item things.
Could you potentially make this even smaller and have the generator fitting inside the phone?
We thought about that, but the problem is that with current phones right now is that there's not enough space. As it is, they're already removing your headphone jack to make place for something else, to make your battery larger. But if you already have this technology small enough, then you can make your battery smaller, so you can fit our built-in system without having to have like extremely large batteries.
So if I could contact anyone in the world for you, a mentor, who would it be?
Oh geez, it's gotta be Elon Musk.
That's what I was thinking. Have you contacted him?
No, no, we have not. We did not even think about it. We are trying to concentrate on the Boston area first, but we did not even think about contacting
Why not?
any big entrepreneurs yet.
You won't get Elon Musk unless you ask Elon Musk.
Well, I'm sure a lot of people are asking for Elon Musk as well.
I might challenge that. I think a lot of people have their own self-limiting beliefs and would say, no, probably everyone's talking to him and he's busy. You might be surprised. You might be surprised because you're already at no. Think about that. You're already at no because you haven't asked.
Yes, that's true. I mean, I'm limiting myself. I'm really blocking myself from asking.
So what's your New Year's resolution?
I guess asking more. I should ask more. Definitely, that's definitely a thing. But the problem with us is that we don't want to go and ask so many like right away. We're really passionate about building this, and we want to try to do it ourselves. We just need that additional help to build it. I mean, one of the things we want to do is really to actually grow the company. We don't want to stay a small company. We want to grow. We have a plan to get as big as we can. Maybe even go public in the future or get bought out by somebody else. But we have a passion for it, and we really are looking to learn. We don't want to just sell out the idea. We want to learn from it. We want to do it.
So what's your big vision? I mean, if everything worked, if all of your dreams worked, what would this look like?
This would be a household name. Everybody would know what the brand name, and we want to be in different product categories. We want to make a difference. At first, we're starting with these basic and the pro model, but again, we want to go into different product categories. But at the same time, we are thinking about how we can help people in war zones and people in third world countries where they don't have electricity. We might want to create like a cheaper model for them. It could be bulkier. It doesn't have to be so small. So people can keep a heat running in their homes, in their tents, for the lights.
I think it's a great vision, and we're running out of time. I appreciate you coming to spend some time with us. And if anyone has any interest in this concept, just send an email to us. Thanks again.
Thank you so much, Michael. It's a pleasure.
Take care, everybody.